Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about how we are going to construct numerical data through graphs techniques. So already we know that in previous video I covered what is the numerical data and what are the various techniques that are available for constructing this numerical data. So actually this numerical data is going to be classified into two types. So first thing is that we can able to implement this through ordered array, and second one is that we can able to represent through frequency distributions and cumulative distributions. So what are the graphs what we are having for implementing this ordered array of numerical data and then frequency distributions of numerical data. So if I'm going to consider this ordered array, so we are having the graph called stem and leaf display graph. And similarly, if I'm going to construct the frequency distributions, what we're having is histogram, polygon, and then okay. So these are the various graphs what we're having for implementing this numerical data. Right, so the numerical data is the thing where you can able to have some numerical values, and categorical data is the other kind of data where we don't have that much of numerical values for that. So for this numerical implementation of this, we have first one is ordered array. So it should be a collection of values which is going to be stored into an array. From that you can able to extract the values, and then this one is going to be implemented through this stem and leaf display graph. And next one is that frequency distribution is the thing, or you can what we call it as cumulative distributions. So for implementing this frequency distributions and cumulative distributions, so we're having histogram is the one kind of graph. So histogram means it should be similar to bar diagram, but where should not maintain no space between the bars. And the polygon is the other kind of the thing where you can able to construct from the histogram itself by taking the midpoint of each rectangle and joining the points with a straight line. What we get is should be the polygon, and give so other kind of graph what can able to represent this cumulative distributions number. So let's see one by one. So ordered array. So ordered array is the thing which should be show some range from min to maximum value, and it should also provide some signals about the variability within the range, and it should may also have the identify outliers that should be unusual observations. And if the data set is large, then ordered array is less useful. Right. So ordered array is the thing which should be a sorted list of the data. Suppose if we're having some data of some not in linear order, at that time what you have to do, you have to make use of first sort the data first. So by setting some limitations, so like min to max like this, and then we should also provide some signals about this variability within the range, and we should also identify the outlier. So outlier means where we can able to treat it as unusual observations should be treated as outliers. And if the data set is large, then the ordered array should be less useful. This is the disadvantage of this ordered array. So say I take an example here. So I'm taking the data here is this. So what we can able to get the values from different sources, and the data what we can able to get from multiple sources should be treated as a raw data or raw form. And the data should be either in ascending order or descending order I have to take in order to implement this ordered array. So here I'm going to construct from largest to smallest to largest values. So once I get able to sort this, then I can able to get the values in ascending order. So first minimum is 21, and next minimum is 24, and again next minimum is 24, 26, 27, 27, like this. I have to sort these values first. Next one is that stem and leaf diagram. So the stem and leaf diagram is the thing where you can able to construct this diagram from this sorted data of the which should be extracted from the ordered array. So this method is the thing is that, so we can able to separate the sorted data by taking the leading digit, what we call it as a stem here, and then trailing digit, what we call it as a leaves here. Okay, the stem and leaf diagram. So we can able to construct from the ordered array values by taking the data, and we can able to take the leading values and then trailing values. So the leading value should be treated as a stem here, and the trailing value should be treated as a leaves here. So this is the simple way of constructing this data set. So let's take an example here. So taken values, what I get previously in the ordered array. So if I'm going to take this, so if I'm going to take 21, so how the 21 should be constructed through stem and leaf here. So from 21, so what I have to take here is, so take 2 as the stem here, and the trailing digit is 1, right? So that should be treated as 1. So that should be stem should become 2 and leaf should become leaf here. So similarly, if I'm going to take some 38 here, so from this 38, the leading digit is 3 and then trailing digit is 8. So like this, I have to construct this stem and leaf diagram by taking the values of this. So after constructing this, what you have to see, this is the stem leaf diagram for the entire data. So let's take the stem here, what should be the stem, and the next stem what we are having here is 3, and the next stem what we here has 4. So identify the leading 3 digits of the stem 2, that is 2. So what is comes here, the trailing digit is 1, so that should be reflected here, and the next trailing digit is 4, and similarly the next trailing digit is 4, and next one is 6, 7 and 7. So like this I have to construct the trailing digit for the stem 2. Similarly, next one, if I'm going to take 3, so the trailing digit is 0, and then trailing digit is 2, and then trailing digit is 8. So like this. And the next stem is 4, the only one I'm having, that should be the trailing digit is 1. So like this I have to construct this stem and leaf diagram again, right? So stem leaf displays the thing where you can able to construct this by taking the leading digits as the stem values and trailing digits as the leaf values. So from this example, I construct how it should be. So first take the values. So just identify the uh, leading digits. So what we're having. So 2 and then 3 and then 4. So 4 I have to take. So then I add it on the what are the trailing digit what we're getting for this stem. So if I take 2, so what should be the stem leading digit is 1. So that one I'm added here. And the next stem is what here 4. And next stem is next leading digit is 4. And next one is 6. And next digit is 7. Next digit is 7. So similarly for 3, so it should be 0 initially, and 2, 8 for full one. So like this. So after considering this is the resultant stem leaf diagram for the given data set. So let's take another example of 100 digit as the stem value now. So for that, what we have to do is first we have to round off to the digit value here. So for this round off this, so if I'm going to take 613 as this value here, so how the stem become or what should be the leaf become? So for this 100 digit number, so what we have to do is first we have to round off to the 10 digit. So that should become 61, and this should become 70, let it be, and 200, like this are rounded up. So what I have to do here? So what should be the stem here? 6, and leaf should be 1. And similarly, stem should become 7 and leaf should become 8. And 12 should become stem and 2 should become leaf. So like this I have to construct for any kind of digit by taking the values to the round up first, and then I have to construct this leaf diagrams, stem and leaf diagram. So see the example here. So this is the data what I get from the other sources. So from this data I have to construct this. So similarly, take the first one 630. Identify the stems first. So what should be the stem? 6 and 7 and then 8 and 9 is the under stem here, and then 10 and then 11 and then 12. So these are the stems initially I wrote it here. So leading digits what I identify. So next one is that, so what we have to do is we have to uh, construct the leading digits for this. So round off this to 10 digit numbers. So what should becomes? So 1 should become, and next 3, and then for this round of 58 I can able to get 6, so 6 I have to write it here. So similarly for this term 7, so what I am going to take here is, so for this term what is the leading round of digits of 17, that should becomes 2, right? So 2 I have to take here. So similarly 2 here, and here should be 5, and it should be 8 here. So like this I have to construct this term and leaf digit for leaf diagram for any kind of digit number. And next one is the frequency distribution. So for constructing this frequency distribution, let me explain what is that frequency distribution. So the frequency distribution is the list, or it may be a table, which should also containing some class groups here. So till now I can able to deal the values only, but here onwards I can able to deal the class intervals as well. So let it be the class groups in the sense of the categories or the ranges within which the data falls should be treated as a class group here, and the corresponding frequencies also have to be taken for constructing this frequency distribution. So these corresponding frequencies means which the data are able to fall within each grouping or the category here. So what is the frequency distribution? So the frequency distribution is that it may be a list or it may be a table, which should contain the class groupings, so where the data should fall within the range, and corresponding frequencies of that each category have to be find it out. So why should we use this frequency distribution? So the frequency distribution is the way to summarize the data, and the distribution condenses the raw data into more useful form, and then should also allows a quick visual representation interpretation of the data, right? So the frequency distribution is the thing which should able to is a way to summarize the data, and the distribution condenses the raw data into more useful form, and it should also allows the quick interpretation of the data here. So next, what is this class interval and class boundaries? So class interval means how to define and how they're going to identify these class boundaries now. So for each class, grouping should have the same width, and determine the width of each interval. So the width of the interval should be defined by the range and the number of desired class groupings, and use at least 5 but not more than 15 groupings here. So the class boundaries never overlap, and round up the interval width to get the desirable endpoints. Right. So the each class grouping have the same width, and determine the width of each interval. So the width of the interval should be done by the range, and should be divided by the number of desired class groupings. So use at least 5 but not more than 15 is the thing, and the class boundaries never overlap, and you have to be round off to the interval width to get the desirable endpoints. So how to construct this frequency distribution by taking an example here. So a manufacturer of an insulation company is going to take some 20 days and record daily of high temperatures. So this is the data of that each 20 days temperature here. So for that, what you have to do, you have to first construct the data into the ascending order. So once we construct this ascending order, what you have to do, you have to first find the range. So how the range is going to be calculated here is find the maximum value and the minimum value, and then subtract it. What we can able to get should be the range. And select the number of classes here. So usually you have to select it between minimum should be 5 and maximum should be the 15 here. So I'm going to select the 5 here, and compute the class interval width. So that should be 10. So how can I able to get this here is, so 46 divided by 5, how much it should be? Nearly 10, that should be rounded off, right? And determine the class boundaries is the next thing. So the limits I have to identify. So the limit should be 10, 20, 30, 40, 50 and 60. These are the limits I have to choose, and compute the midpoints here. So midpoints between in between the two values. So 10, 20 midpoint is 15, and 20 and 30 midpoint is 25. And then finally count the observation, assign the values here, right? So once data comes, so first of all you have to arrange it into the ascending order. So after constructing this, so you have to first find the range, maximum value minus minimum value, and select the number of classes, and compute the class interval, and determine the class boundaries, and compute the class midpoints is the thing. See this here. So I am going to construct a table for frequency distribution. So for this, the class should be 10 to 20, and then how many number of times in between 10 and 20. So 12, 13, and then 17 is the value in between 10 to 20. So the frequency is 3. And next one is that in between 20 and 30, how many values are there? So 21, 24, 24, 26, 27, and 27. So totally 6. So I can able to construct the frequency 6. And in between 30 and 40, 30, 32, 35, 37, 38, 5. So the frequency is 5. So in between 40 and 50, 41, 43, 44, 46. So totally 4. So 4. And in between 50 and 60, where what we're having is 2. So same thing I'm taking here. So count of this. So totally I'm getting 20. And finding out the relative frequency. So the relative frequency should be 0.5 and 0.30 for this 0.25, 20, and then totally 1. And from the percentage should be 15, 30, 25, 20, and then 10. So once we constructed this, then we have to construct the histogram, what the graph, what we are having for this constructing this. So the graph of the data and frequency distribution is called histogram, and the class boundaries or the class midpoints are going to be shown on the horizontal axis, and the vertical axis should be either frequency and relative frequency or percentage I can able to take. So the bars of the R should be appropriate heights are going to be used to represent the number of observations within the each class. Right? So the frequency distribution is the thing you should able to construct through histogram. So for this constructing histogram, what we need is class boundaries, and then class midpoints is needed. And so for the vertical axis, what I'm going to take is frequency and relative frequency or percentage I'm going to take here. So see how we are going to construct this histogram. So for this, let me construct this histogram and identify the class. So the class midpoints is 5, 15, 25, 35, 45, 55. Take the frequencies on x-axis here, right? So what is the frequency in between 15? It should be 0. So same thing. And in between 20 and 30, so in between 20 and then 30, so sorry. So in between 20 and 30. So what is the value? Sorry here. So in between 10 and 20, what is the frequency here? So 10 and 20, the frequency is 3. So let me take 3 first. And then in between 20 and 30, the value is 6. So construct 6 here. And in between 30 and 40, 5. And between 40 and 50, 4. And in between 50 and 60, it should be 2. So like this, I have to construct the histogram. So like this, I have to construct the histogram. So can also construct the histogram by taking an Excel here. So for this, what I have to do is take an open an Excel and go to tools. So I can able to go to this option data analysis. So after selecting this, select the option like histogram, and then select input range and bin range here. So after clicking this, the pop-up window will be open. From this, what you have to do is you have to select this chart output and then click OK here. So next, how we're going to construct this frequency polygon here. So the frequency polygon is going to be constructed from the histogram. So from this, so what I have to do here is, so first we have to construct the histogram. So already constructed histogram from previous slide, right? So how to construct this frequency polygon now? So the frequency polygon is going to be constructed after constructing this histogram. So for that, what you have to do is, so first select the midpoint of each rectangle. So after selecting this, joining all the lines of the midpoints and the graph, what I can able to get, that should be the histogram after deleting this. So like this, I can able to construct the frequency polygon from the histogram value. Right. So this is the graph. So initially, what I'm having here is 10 to 20. And then 20 to 30, and then 30 to 40, and then 30 to 40, and then 40 to 50, and then 50 to 60. So initially like this. So after eliminating this all this rectangle, what the curve that I'm getting, that should be the frequency polygon. And next one is that cumulative frequency, how to construct this cumulative frequency. So up to till now, I told how to construct the frequency in percentage, how the frequency, cumulative frequency is going to be constructed, and then cumulative frequency and cumulative percentage. So the cumulative frequency means first we will take the values of initial frequency, that is 3. From that, what I have to do is, so they add this 6 next frequency to the value, that should becomes 9, and from this 9 add 5, then it should becomes 14, and plus 4 add it 18, and 18 plus 2 how much, 20. So like this I have to construct the cumulative frequency. So similarly construct the cumulative percentage as well. So for this cumulative percentage, take the initial value, that should be 15 here. So from this 15 add 30, then cumulative fraction 45, and the next is 25, that should become 17, 70 becomes 90, and 90 plus 10, 100. Like this, you have to consider the cumulative frequency as well. So by taking this cumulative percentage, so take the class interval, so less than 10, 20, 30 class intervals, similarly I'm taking, and then cumulative values I'm going to be considered here. So first should be 0, and next should be 15, and next should be 45, and next should be like this. I have to construct this. So 10, 0, then 20 it should be 15, and 30 it should becomes 45, and 40 it should be 70, and 50 it should be 90, and 60 it should be. So like this, how to construct this frequency polygon. And next one is that scatter diagram. So scatter diagram means this should be useful for constructing bivariant numerical data. So the bivariant consists of a pair observation that is going to be taken from the two variables. So scatter diagram is the thing which should be used for bivariant data only, and the bivariant consists of the pair observation that is going to be taken from the numerical value. And scatter diagram is the thing, the one variable is going to be measured on vertical axis and other variable is going to be measured on horizontal axis. So the variable what I took, that should be the vertical axis, and another variable that should be the horizontal axis. So scatter diagram, so this is the data what I'm having initially, so volumes per day and then cost per day. So how to construct this scatter diagram? So take the values of volume per day on x-axis and then cost per day on y-axis. So for this volume 23, so what is the value here? 125. So mark it, and then 26 it should be 140, and 29 it should be 146, and 33 it should be 160, and 38 it should be 167. And 42 it should be 170, 50 it should be 188. Like this, how to construct the scatter diagram. So I can able to construct this scatter diagram in Excel as well. So by taking the open the Excel sheet and then click on the bars and then select the option XY scatter, and then from that you can able to select the scatter diagram. Select the option scatter, and then that should be what kind of scatter diagram you can able to choose. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.